You're watching A-League
Math. Samuel Kim Production.
Section 4.3 is where we're at today. We're going to be talking about trigonometric ratios. And a lot of this stuff you've actually seen before in pre-calc 11, but I thought I'd review it with you here before we actually introduce that new stuff that you'll learn. But recall this from pre-calc 11, where I asked you before, how is each trig ratio related to the coordinates of a point P? Of course, the point P has coordinates x, y, and the radius r. Let me ask you to quickly draw a circle for me, please. Thank you. Of radius r. Okay, and let's call this point here P. And remember how even last day we actually did this, where we drew a right angle triangle. This is x and this is y. And remember those definitions for sine, cosine, tangent? Yeah, it's SOHCAHTOA. So sine equals the opposite over hypotenuse. If this is the angle theta in question, then the opposite side is which one? The r, the y, or the x? If you said y, you are correct. And of course the hypotenuse is r, so y over r. We've got cosine, which is adjacent over hypotenuse. That would be, of course, x over r. And tangent, of course, is opposite over adjacent, so y over x. And what's the relationship between x, y, and r? Well, I hope you remember from last time, or even last year, that x squared plus y squared equals to r squared. Really, it's just Pythagoras again. Okay? Well then, I think last day we talked about the unit circle. So how does this stuff relate to the unit circle? Well, once again, we've got a circle, but the key difference now is that the unit circle has a radius of 1. Still have a point x, y. Still draw a nice right angle triangle with x and y. Still have this as the angle theta. And we're going to still find these ratios. So sine theta is just y, because it's opposite, over hypotenuse over 1. Or, of course, that just equals to y. Adjacent over hypotenuse for cosine is x over 1. Or, once again, that just equals to x. Tangent, though, opposite over adjacent, didn't really matter what r was, so it's still y over x, just like before. Okay? Well, before I do that box to the right, I'd like to take a look from last day too, that crazy unit circle that I drew, yeah, and all those different values. Okay, I've reproduced it again for you here. Thank goodness you don't have to do it. Okay. I guess what I'd like to do is just pay close attention to one of these values, and let's see how they relate to this sine, cosine stuff. Okay. The value I'm going to ask you to look at here is the 30-degree value right here. Okay, 30 degrees, or pi over 6. Okay. What's our definition for the x coordinate again in a unit circle? It looks like it's cosine theta. So x is the same thing as cosine theta. So this value of root 3 over 2 must be cosine of theta. The theta in this case is 30 degrees. Well, what's the y value going to be then? And if you said, hey, the y value is sine theta, you are correct. Okay. And by the way, you can double check this by plugging these in your calculator. Okay. Let's try another one just in case. How about this one over here? Let's try something like this. I'll do this triangle. How about 120? Okay. This angle here, of course, is, I think, well, I won't tell you what that angle is. Don't really need it. Okay. Oops, I want that triangle. In this case, what's my angle theta? So I guess what's this angle theta here? The angle theta is 120 degrees. So once again, the x coordinate, or cosine, this should be cosine of 120. And by the way, let's just actually calculate that on the calculator. I'm going to bring mine out. Bring yours out if you can. Make sure you're in radian mode, or sorry, degree mode, because I'm using degrees. So I'll change this to degree. I just pressed mode, by the way. That's what I did. Okay, second, quit to get back out. Cosine 120 equals to negative 0.5. Correct. Okay, what would that other answer be here? Or the other angle, root 3 over, not angle, the other coordinate, root 3 over 2. That's just sine of 120. And if you do that, I think you get the equivalent of root 3 over 2. And if you're not too sure, root 3 divided by 2. Yes, it's the same thing. So, what do you notice about the angle theta and how that's related to the coordinates x, comma, y? So now let's go back to this box to the right. It says if the point of theta, so this is where x, comma, y is related to that angle theta, or the angle, that's the standard position angle. If p of theta equals to x, comma, y, if this whole thing is a point on the terminal arm of an angle theta that intersects the unit circle, then what do we know about cosine theta? Well, in both those illustrations here, cosine of theta represented the x coordinate. And then sine theta, in those two illustrations, represented the y coordinate. So therefore, if I want to describe p of theta using, instead of x, comma, y, using the actual theta, or the angle, well, the x coordinate is just cosine theta, and the y coordinate is sine theta. Okay? For your information, FYI, what's tangent again? Tangent was defined as y over x in our knowledge over there. But we now know that y is the same thing as sine theta, and x is the same thing as cosine theta. So we come up with a nice property here where tangent theta is actually just equal to sine theta over cosine theta. Okay? This is just a brief introduction. We'll see more of that later on in chapter, I believe, 6. Yes, we're doing trigonometry for the next 3 chapters, 4, 5, and 6. Don't like this stuff? Sorry. But anyways, you'll see that again. I just thought I'd show you. And as a quick extension, remember the idea of the equation of the unit circle from last day? Go back to your notes if you're not too sure, but it's x squared plus y squared equals to 1. Well, knowing now that x is the same thing as cosine theta, I can write this as cosine theta all squared plus sine theta all squared, and that equals to 1. This is called the Pythagorean relationship, or Pythagorean identity. You'll learn once again more of this in chapter 6. Okay? But for today, let's move on to page 2. And I'd like to just quickly review the 3 primary trig ratios, which are once again sine, cosine, tangent. And I want to introduce to you their cousins. Yes, they have cousins. Each of the 3 primary trig ratios, by the way, the primary ones are sine, cosine, and tangent. Okay? They have corresponding what we call reciprocal trig ratios. So there actually is 6 that you need to know, not just 3. Reciprocal, you should have heard last year. That's the idea of 1 over. Well, cosecant theta is the same thing as 1 over sine theta. Okay? Now, remember sine theta from last page was y over r. So the reciprocal of y over r must be r over y. Secant theta is equal to 1 over cos theta. And you need to memorize these, by the way. And remember, cosine is x over r, so this just becomes r over x. Okay, so this is what they call cosecant. I should write down the words. Cosecant. This is called secant. And the last one's called cotangent, so you know what that one's related to. Yes, that's 1 over tangent. Since tangent was y over x, this just becomes x over y. Okay? Sine, cosine, and tangent are called, once again, the primary trig ratios, where secant... I made a mistake here. Sorry. This should be not cosine, but cosecant. Change that, please. Cosecant, secant, and cotangent are called the reciprocal trig ratios. Okay? So know these definitions, box this. This is something important. Please memorize. Okay? Memorize. Please. Okay. Well, let's try one of these examples and let's see if we can figure out these trig ratios. Well, here we go. We have a point -5, 13, and 12, 13. It lies at the intersection of the unit circle and the terminal arm of some angle in standard position. If I were to ask you to do a quick drawing, I guess here's where it would be. -5 13ths. Probably 12 13ths is up here, so probably a point like this. Okay. Draw a diagram. Oh, I just did that to model the situation. And determine the values of the 6 trig ratios. So what I need you to do is really find me all the sides. Okay? This is a unit circle, so the hypotenuse is equal to what number? 1. Good. What's the vertical distance here? Well, this must be 12 13ths because I told you the y value is 12 13ths. And over here, the horizontal distance must be -5 13ths because guess what? That is the x coordinate. So, let's write these out. Sine theta. Now, once again, sine is defined as y over r. So, all you need to do is just take 12 over 13 divided by 1, which is just 12 over 13. Cosine theta, let's do that. How is that defined? It's x over r, or I guess in this case I didn't even need r because it's the unit circle, it's just 1. So -5 over 13 divided by 1, or just -5 over 13. That makes sense, right? The x and y coordinates. Tangent, how about tangent? Well, tangent is the same thing as y over x. So in this case, y value is 12 over 13, x value is -5 over 13. Remember, 12 over 13 divided by -5 over 13. That's the same thing as multiplying by the reciprocal. And I know I'm showing probably an extra few steps for many of you, but that's okay. We'll divide out, and there we have it. 12 over -5. Okay. Those were the primary. Guess what? I said find all 6, so now you need to find the reciprocals. The reciprocal of sine is cosecant, CSC, and that's defined as r over y. Well, in this case, I'm not going to do all the extra stuff. I'm just going to flip the 12 13ths and make it 13 over 12. Cosine's reciprocal is secant theta, SEC, so that would be r over x. That would just be 13 over -5. Tangent's reciprocal is just cotangent, that's x over y. I'll just take the final answer and flip it. So that's just -5 over 12. Okay? Done. So, as practice, I'm going to ask you to do example 1b. This one's a little bit different because it's not on the unit circle, but nonetheless, it's the same. I'll help you with the first part, and then I'm going to ask you to draw or write out all those 6 ratios. Okay? That's an ugly circle. Six, -8. So 6, -8. In this case, you need to actually figure out what r is. So remember the equation of the circle, x squared plus y squared equals to r squared. That means x is 6, y is -8. So 6 squared is 36, 8, 64, r squared. 36 plus 64 is 100 smackaroos, so r must be 10. By the way, there's no negative here because r is always a positive number. It's a radius, it's a length, it's 10. Okay. You do the rest. Y is -8, 10, -4/5, 6 10, 3/5. Y is -8 over 6. How about -4/3? Then I'm going to ask you for the reciprocal, so cosecant theta, that's just r over y. I'm just going to flip it, that's 5 over -4. Cosine is just secant, once again r over x. I'm just going to flip it, 5 over 3. Cotangent is x over y. Going to flip it. How about -3 over 4? Okay, feeling good about these reciprocal trig ratios? All right. Let's move on to page 3. We're going to do some more review of grade 11 stuff and just now add in this new stuff with the reciprocal trig identities and also those angles measured in radians. Okay. Hopefully you remember this stuff, the exact values for trig ratios, and if you don't remember, well, go look back at your pre-calc 11 notes. Okay, these come from the special triangles. Those are actually on section 4.2, so you can go back there and look at them too. But what I'd like you to do is just find out what sine of 0 is, sine of 30, sine 45, sine 60, and sine 90. Okay? Look back at that unit circle if you wanted to. Okay? Sine, once again, is the y values, right? So y values on unit circle. Do you know what I'm talking about right now? Go back to page 1. Yeah, unit circle. Right, this one, right? Sines all the y values, so sine of 0 is 0. Sine of 30 is 1/2. Sine of 45 is root 2 over 2. Root 3 over 2 and 1. So, right, they're all there. Pretty snappy, hey? 0, 1 over 2, root 2 over 2, root 3 over 2, and this was 1. Cosine, go back and take a look. I know what they are. You go take a look. Tell me what they are. Yep. The x values. 1. Root 3 over 2. Root 2 over 2. 1 over 2. 0. Tangent. Well, that's not on it. But tangent is defined as y over x. So I can take the sine value divided by the cosine value, right? And I told you that too earlier today. 0 divided by 1 is 0. 1/2 divided by root 3 over 2 is 1 over root 3. Or, for those of you who like to rationalize the denominator, root 3 over 3. Root 2 over 2 divided by root 2 over 2, that's just 1. This one's root 3. And 1 divided by 0 is, undefined. Here's that special angle chart that I want you to also memorize. Now, some of you are thinking, Mr. Lee, there's so much memorization. Yeah, I know. It'll help you out later on if you can. And if you can't, well, that just means you'll be much slower. This chart is particularly important. And if you're really unsure of how to memorize this, let me just tell you really quickly how this can be done very easily. Let's just look at the sine theta row. Okay, I like patterns. Okay, if things are looking alike and in pattern form, I think it's much easier to understand and also memorize. So, seems like everything has a denominator of 2. So what I'm going to ask you to do is rewrite the 0 and the 1 with the denominator of 2. I guess that'd just be 0 over 2. And this one over here would be, I guess, 2 over 2. Cool. So now everything has a denominator of 2. Well, look at the numerators. I've got roots. Well, I've got root 3, root 2. Well, can't I write this as just root 1 over 2? Right? Same thing. I'm trying to make them all look alike. And then what about 0? Well, isn't 0 the same thing as root 0? Oh, yeah. So now we have root 0 over 2, root 1 over 2, root 2 over 2, root 3 over 2, and 2 over 2. Well, how do I write 2 as a root? Oh, yeah, it's root 4 over 2. See the pattern now? Root 0, root 1, root 2, root 3, root 4, all over 2. So that helps. Great. If not, forget it. How about cosine, though? If you notice about cosine, it's actually sine, but backwards. So we have here root 4 over 2, root 3 over 2, root 2 over 2, root 1 over 2, and root 0 over 2. Okay? So technically all you need is just the first row of sine. Cosine is just the first row of sine backwards. And tangent I don't memorize, but I do memorize that tangent is sine over cos, and I just take the numerators of each of the sine and cosines and divide. So root 0 of root 4, that's 0. Root 1 over root 3, there we go. Root 2 over root 2, that's 1. Root 3 over 1, root 3. Root 4 over 0, undefined. How's that? Pretty crazy. And I hope you also remember this, the signs of the trig ratios, telling me where it's positive and negative, and this idea of the relationship between theta and theta r. Okay, go back to your trig stuff in grade 11 if you don't remember. But the signs of trig ratios, let me just quickly tell you this. There was an acronym for it. ASTC, remember that? I say all students take calculus. Okay? I know, you probably don't. Whatever. Calculus, cooking, Chinese, whatever. Some C word. Okay? And what that says is that in quadrant 1, all of the trig ratios are positive. In quadrant 2, only sine is positive. In quadrant 3, it's tangent. And in in quadrant 4, it's cosine only. Okay? That is positive. Then I want you to recall this relationship between theta and theta r, and I'll show you why we need all this stuff in a second. But remember, if your angle's in the first quadrant, well, theta is actually equivalent to theta r. If your angle is in the second quadrant, right, here's the angle, well, in this case, the angle is equivalent to me taking 180 degrees, going that half circle, and minusing theta r. If it was in quadrant 3, that's this angle here, that's theta. So, of course, theta is equal to 180 degrees plus theta r. And if it was in the fourth quadrant, we're going all the way around almost a full cycle. Well, in this case, it's the full cycle minus theta r. And that's how you find the angle in the fourth quadrant. These two ideas, along with the trig ratio table from above, should allow you to calculate exact values of trig ratios. We did this last year, but now I'm going to throw in a complexity of radians and also the complexity of, you guessed it, reciprocal trig ratios. Okay, let's go. Cosine 2 pi over 3. I'm going to draw a picture. It helps me out. Where is 2 pi over 3? I think it's in quadrant number 2. Okay, confirm that with me if you can, please. Well, to find the exact values, what we need to do is actually find the reference angle. What's this reference angle here? Theta r. Well, remember, going a full cycle is 180, but in terms of radians, it's pi. So pi minus 2 pi over 3. That's the same thing as 3 pi over 3 minus 2 pi over 3. That, of course, equals to pi over 3. So what we're saying is this is equivalent to cosine of pi over 3. Almost. This angle is in quadrant 2. Is cosine positive or negative in quadrant number 2? ASTC, remember, S is sine, so this is negative. So we have to put a negative sign in front. Okay? Now, why is this going to be useful to us? Well, now we should be able to calculate what cosine pi over 3 is by using the special angle table. Going up to the special angle table, oops, I forgot to actually tell you what these things are in radians. What is 0 degrees in radians? Well, 0. 30, hopefully you remember, is pi over 6. 45 is pi over 4. 60 is pi over 3. Ding, ding, ding. And 90 is pi over 2. I asked for cosine of 60, which means I look at the chart and I know it's 1/2. So therefore, from the chart, okay, from the special angles chart, this equals to 1/2. Gotta bring down the negative, don't forget. So there's my answer, negative 1/2. Okay. We'll try part B together. This one is where, once again, you gotta figure out where 7 pi over 6 is. The hardest part sometimes with these radians is figuring out which quadrant it is. This, of course, is more than pi, so I'm thinking it's going to be in quadrant 3. And once again, I want to find theta r. Theta r in quadrant 3 must be that whole angle, 7 pi over 6. Take away. Take away what? That angle of pi, right? Because this is pi. So I'll say that's what? 7 pi over 6. I'm just realizing right now that what I wrote for you earlier, you know this thing up here? I wrote it in terms of theta. Maybe I should have wrote it in terms of theta r. Does it matter? Okay, I'll do it for you anyways. Okay, sorry about this, everybody. Or, if I were to move theta r to the side, theta r is equal to 180 minus theta. So the reference angle is equal to 180 minus theta. Over here in quadrant 3, once again, if I were to solve for theta r, that would be theta minus 180. I'm just doing some algebra, okay, moving the 180 to the other side, isolating theta r. And in this last one, if I were to solve for theta r, if I move that to the left side, bring the theta to the right side, that's 360 minus theta, okay? Don't know if that helps you or not, but it seems like that's what I'm using down here in example number 2. 1, 2, 3, 4. Okay, so for part B now, what we just found is theta r, the reference angle is pi over 6, so this is equivalent to sine pi over 6, right? Almost. This angle is in quadrant 3. Go back to that ASTC thingamabobber. Is sine positive or negative in quadrant 3? It's negative, right? Okay. And then we'll go to our special angle chart. Sine pi over 6, what's that equal to? That's 1/2, so I guess this one is also equal to negative 1/2. Done. Okay. I'll do C and D with you, or C and B it says here. Okay. Cosecant 315. Well, what's that equal to? Cosecant is the same thing as 1 over, and if you guessed it, that's 1 over sine. You're correct. So ultimately, sine 315 means you are in the 4th quadrant. That whole angle is 315. What's the reference angle? That would be 360 minus 315. You guessed it, 45. So this is equivalent to 1 over sine of 45 degrees. But because this is in the 4th quadrant, once again, we'll make this negative. Your job now is to figure out what sine 45 is from the special angle chart from above. I believe it's just root 2 over 2. This looks ugly, so we'll try to flip it around. That's the same thing as 1 divided by negative root 2 over 2. So I'll write this as negative 2 over root 2. And if I ever ask you to rationalize, because mathematicians don't like having the root 2 in the bottom, and by the way, you don't necessarily need to do this. If you leave your answer like this in green, I'd be perfectly happy with it. But if you do, negative 2 root 2 over 2, well, that's just negative root 2. Done. Okay. You try cotangent pi on your own. pi is an interesting one, because that's 180 degrees. It's actually not on your table. But remember, tangent is defined as what? Tangent is defined as y over x, right? So all you need to do is go back to your unit circle drawing on page 1 and look for where pi is. Oh yes, pi is right here at 180 degrees. Well, the y and the x, 0 and -1. Perfect! Back to our notes. So that's 0 over -1. That's 1 divided by 0. And what's 1 divided by 0? Yeah, that's undefined. Trippy. But that's the answer. Okay. Now you might be thinking, Mr. Lee, do they all have this special angle property? Nope. So if you turn to the next page, once again, most answers actually aren't special angles. They are approximate values. Yes, approximate values. So, I guess what you need to do here is actually just use your calculator, because that's all you can do. Secant of -280, well, that's just 1 over cosine of -280 degrees. So just go use your calculator. Make sure you're in degree mode, by the way. So mode, oh good, I'm in degree already. And just punch it in. 1 divided by cos -280. I asked for 4 decimal places, so 5.759. Okay. Whoa. Lag time. Okay, this one here, tangent -7 pi over 11, so I can just type this in right away. -7 pi over 11. By the way, is this a radian measure or a degree measure? Yes, no degree sign. It's a radian measure, so make sure I change my calculator back into radian mode. Don't make that fatal mistake. Then go back to your calculation screen, then press enter, and there's the correct answer, 2.1897. Okay. If you're not too sure of the keystrokes, go back and review what I just did. You can write down the keystrokes yourself beside the question. Okay. I know this video is a little bit long, but I want to finish this off. Okay, this last part's pretty important. And this will set you up for success during or doing section 4.4 as well. Okay. We've figured out the ratio when you're given the angle. Now, what happens if we were told to go backwards? Meaning I give you the ratio, it's your job to find the angle. Well, we've done this before too, so it's not like this is too hard. But we're going to extend it just a little bit here in grade 12. Well, remember how we find this? Sine theta equals 0.75? Yeah, all we did was we took or got rid of the sine by doing what we call inverse sine, or sine minus 1. And this we, of course, do in your calculator. So back in grade 10, when you learned this for the very first time, this is what you did. By the way, make sure I'm in this case, degree mode, because look at my domain. It's in degrees. And now I'll press enter, I get 48.6 degrees. Cool. Back in grade 10, we said that was it. But then in grade 11, we're like, wait a minute. Remember, sine has 2 angles? Yeah, ASTC, where's sine positive? In quadrant 1, which is our angle 48.6, and also in quadrant 2, which is over here. How do I find this angle in quadrant 2? Well, that would be 180 minus the reference angle that we've calculated of 48.6. And so what is that? I think that's 131.4. 2 answers. Remember that? Yeah. Okay. Here's a trick. For next part, part B, well, guess what? We're in Math 12. We are dealing with radians instead of degrees now, so we're going to do the same type of thing. Find all the answers between 0 and 2 pi. This is for tangent. So our first step, of course, is to get rid of that tangent function by doing the shift tan or inverse tan or tan minus 1. And of course, you have to do this with your calculator. Because the domain is between 0 and 2 pi, what mode must we be in? Yeah, radian. Okay. And just go ahead and type this in. Tan minus 1, negative, root 3, close the bracket, divide by 5, close the bracket. There we go, 0.33. I said round to the nearest tenth, so let's call this negative 0.3. Okay. Interesting enough, this is not in my domain. Oh, sorry. So how do we bring this back into the domain? Remember, this is the idea of coterminal angles, so I'm going to add to it. Okay, I'm going to say not in domain. So in order to make it there, I'm going to have to add something to it. How about adding 1 cycle, which is 2 pi? So I'm actually going to keep 2 decimals this time, just so that we have a little bit more accuracy. I'm going to add to that 2 pi, and we have here 5.95. Okay, so that answer seems to fit in my domain. That's one solution. Now, where's my other solution going to be? This is where that ASTC thing comes into play again. All students take calculus. Well, this is a tangent ratio. It's negative, so it must be in quadrant 4, especially when that number is so big. So this must be 5.95. What do you think the reference angle is? Because we need to find out the reference angle. If you said that's just 2 pi minus 5.95, you're correct. And that's actually 0.33. So knowing this, where is my other answer going to be? Where else in this grand scheme of things is tangent negative? What quadrant is tangent negative in? Quadrant 2 would be the correct answer, yes. So we're looking for this answer now. So what's this theta in black? Well, of course, that's in quadrant 2, so it's 180 degrees, or pi. Take away the reference angle of 0.33. And what's that? 3.14 minus 0.33. Something like 2.87 or 2.81. Okay, so there's your other answer. 2.81. Ta-da! Okay. I think those are a review. Here's the new stuff. So let's just finish off these two. Sorry this video is long. Didn't mean to be that long, but let's just finish it off. Okay? Secant theta equals to 2. Well, there's no secant inverse button on your calculator, so let's rewrite this as 1 over cosine theta equals to 2. Once again, we can do cosine, and I guess what we should do is try to solve for cosine, not 1 over cosine. You kind of flip both sides, or for those of you like cross multiplying, I guess you're doing this. 2 cosine theta equals to 1. So cosine theta equals to 1/2. You see why I like just to flip? Much simpler. And then solve for theta now. We can do that. So theta equals to cos negative 1 of 1/2. This is a special angle, which is great. I'll go up to my chart. You do the same. I'm not going to do it. I'm actually lazy. I know this answer is 60. You double check it. I think it's 60. Once again, this secant or cosine ratio is positive, so where else is cosine positive? How about quadrant 4? Okay, so theta also equals to 360 minus 60, or how about 300 degrees? Okay, 2 answers. Alright, last but not least, cotangent theta equals to root 3. Of course, you know that cotangent is the same thing as 1 over tangent. Once again, I'm going to just do a shortcut. I'm going to flip it around. So I'm going to flip the other one. That's over 1. This seems to be also a nice special angle. If I do tangent minus 1 over root 3, that equals to just the beautiful angle of pi over 6. And because I'm looking for tangent, and where is tangent positive, we have pi over 6 here in the first quadrant, but there seems to be also another angle over here in the second quadrant. Don't know why I only have one color, but oh well, we'll keep going. That's of course pi over 6 plus pi, which is the same thing as 7 pi over 6. We would be done with 2, but unfortunately my domain said go between negative 2 pi and 2 pi. So once again, that practicing the coterminal angle stuff, we're going to have to go backwards. So may I strongly suggest your other angle here would be what? Pi over 6 minus 2 pi, which would be minus 12 pi, which would be negative 11 pi over 6. So there's another answer in this case, because of our domain. And the last one, how about 7 pi over 6 take away 2 pi, or of course that's just 12 pi over 6. And how about negative 5 pi over 6 as well. Whoa, trippy. Oh well, I guess I'm done.